Hi there, this is Dr. Bainton again for round 2 of e-learning. I'm going to teach you today about how to, I don't know, build a BattleBot, I suppose. So you want to build a BattleBot. What I'm going to start out with is first showing you kind of the frame materials, the materials that you can actually use to build the BattleBot. I'm going to assume that someone in your group has already catted a frame from the previous semester. So what you're going to do is you're going to go ahead and just keep using that frame from previous semester, or you can even recat it and make those bearing blocks associated with or the gearbox associated with actually making your robot move around. Those are things that you can put together on your own. I'm not going to cover that here. What I'm going to cover here instead is first how to make the different extrusions that we have available for us, and then also the an example piece that you may want to create. Okay, so one more thing I want to emphasize here is that we're going to take a top-down approach. Um, Basically, as this project moves further and further onwards, we're going to make the whole thing a little bit more realistic. But we're going to start off with our design as kind of proof of concepting or getting ideas out onto the computer, and then starting to make it form in such a way that you can actually put your parts together, and that will start to make sense over time as soon as I get into this. All right, so I'm going to go ahead and create a new part again, as I've always done. So first off, I'm just going to show you how to create a box channel for those of you who have forgotten how to create a box channel. And so here I go. I'm going to go to Features. I'm going to go to Extruded Boss Base. And I'm going to click on any one of the planes, depending on which plane I want the box channel to extrude from. Then I'm going to create a center rectangle. I can even make oh yeah, you can see that I have selected from midpoints for my construction lines, and you'll see why that's the case. Sweet, take a look at that. And now I'm going to smart dimension this as 2 inches, because our box channels are actually 2 inches by 1 inch now. They're no longer that strange 2.01 inches or 51.2 millimeters anymore. They're now actually 50.8 millimeters. Okay, so there's my smart dimensioning of my box channel. I'm going to offset the entries of here. I'm going to reverse that, and remembering that it's a 2 millimeter wall thickness for my box channel. Considering that these are in fact BattleBots, there's no reason for you to skimp on weight and try to make things light at all. You're making your robot tough and durable. Okay, so there we go. I'm going to exit the sketch, and now I'm going to make this say like 10 inches long. So now this is a pretty long box channel that I've now created. Actually, we'll just make it 12 inches for the to correspond with freedom units. Okay, so here's my box channel. Now, for the pieces that we have in the lab, what I want to kind of talk about is ideas that people use for BattleBots. Now, you can go on the internet and look at all sorts of BattleBots. Essentially, you have two types. You have a type that's trying to saw the other one in half, and another type that's essentially trying to flip the whole robot over. There's probably some other types that are trying to like impale or whatnot. But let's go with something simple. So let's say that I had this box channel and I want to use it as a flipper, for instance. So the simplest thing that I could possibly do is on the side of my box channel, I want to turn it into a wedge instead. And so what I'm going to do is I'm going to go to Extruded Cut. I'm going to click on the side face of it, and I'm going to do something pretty simple where I create a line, go from here to anywhere around here. Really, it doesn't actually matter. To here and then back again. And I can smart dimension this if I really want to. It doesn't really matter. If you really want to, to make sure that this is at a proper angle, let's say that you want to make sure that it is no more than or no less than 30 degrees or no more than 30 degrees when it touches the ground. So I'm going to turn this into 30 degrees here, and I'm going to exit this sketch. and then it shows me this cut extrude, and I'm just going to, instead of blind, I'm going to go through all, which means cut away everything in its path, and I'm going to click on OK, and now you see that I have this nice little wedge. So this is kind of a this could be kind of a thing that's attached to a robot, and it pivots about some center here. So you can see that now I have my perfect little device that can flip other things if you put a hex shaft through here to actuate this actual my little flipping device. So this is one flipping device. Now, this is clearly not great because, first of all, manufacturing this is not super easy. There's other issues with it, that the actual hex itself, the hex hole itself, will strip pretty quickly if you put any sort of force on the edge of this. And so this is not ideal. Specifically, you would want to have a nice hub here that could withstand a ton of force that would purchase a lot with the actual box channel itself. So there's a few things that make this make this not particularly great, and just actuating it in general. So, for instance, but this would be something that you would place into the assembly of your robot, and then you would decide on how it actually fits there or how to put things on. So this is what I mean by a top-down approach, where I create the mechanisms that I want first, and then I figure out how I'm going to actually properly incorporate it. And I'm just kind of making like a toy mechanism here, where this has the idea where it can possibly work. Now I have to put it into the actual assembly to see how it would work itself. And then I can come back here and also change the lengths and the dimensions to make it fit in a way that I want it to fit appropriately. So this is one particular example of a mechanism that you might use. And it's not particularly nice or anything, but this is one of the two types of things that we have in the lab. Essentially, we have sheet and we have box extrusion or tube extrusion. So we have round tube and box tube of various sizes, but typically for box tube it's 1.5 by 1, or sorry, it's 2 by 1 inches, but we also have 1 by 1 inch box channel as well. Okay, so I'm going to go ahead and just close this file because it's not worth saving, and then I'm going to make a new one. And this one here, this is I'm going to make an example of a wedge, and what this wedge will help you understand is kind of, you know, what is the what's the purpose of, or how are we going to use sheet. Okay, so let's say that I wanted to make a kind of a plane that my robot can or a planer that my robot can attach to, and as it drives around, it just essentially snow plows other robots. So what I can do is I can make a sheet and kind of make it out of it from there. So I'm going to go ahead and again create a center rectangle. And what I'm also going to do, just to make my life easier, is I'm going to highlight these two edge lines here, and I'm going to make them for construction. What that does, I hope, is make it like 15 degrees instead. There we go. And I'm going to exit this sketch. And so now you can see that it's trying to extrude this thing because I took out these lines, or I made these lines construction lines. So let's say that I want to be able to bend this metal. I can typically bend 1/8 sheet metal. So I'm going to do that and go ahead and I'm going to bend 1/8 sheet metal. I'm going to press OK to that. And now what I'm going to do is I'm going to make this piece of metal bendable. To do that, I need to go to Insert Sheet Metal, and then Convert to Sheet Metal. And I'm just going to go ahead and sheet thickness, okay, whatever. I think this sheet thickness should be 1/8. And then the bend radius, I'm going to make that not 1/8. I'm going to make that something else. I'm going to make that 1/4 inch instead, just to make it super easy. And then make sure that I'm converting the correct face. Okay, so I've made that face. I'm now going to go to Tools, or sorry, Insert, Sheet Metal, and I'm going to make a sketched bend. Here. I'm going to click on this, and now I'm in a sketch. So what this sketch does is it tells I have to draw lines on the sketch that I want to bend. So I'm going to go from this corner here, and I'm going to make sure that it's vertical and intersecting with that side there. And then I'm going to make another center line that goes through here. And I'm going to mirror the entry as I usually do because I like lines, I like objects to be related to each other, so if I ever make a change, the other one will get changed automatically. I'm going to go ahead and I'm going to exit this sketch, and I'm going to ask for the bend parameters. I think I just click anywhere on here. Yep, so now I've clicked anywhere on here, and now I have my sketched bend. Okay, and so I can press OK to that, and now you can see that I've made a nice little wedge that I can put at the front of my robot that will pop up another robot. Now, one thing that happened that was a little bit weird was that I created this so that it's tilted downwards, and these little things here are stuck out. So I can do one of two things. I can either make an extruded cut right now, so let me try to make an extruded cut on here, and then I'm just going to make a line that is from here to there. And I want to make sure that these are perpendicular, so I'm going to hold shift between these two and say they're perpendicular. I'm going to exit this sketch, and then I'm going to click on for selected contours. I'm not going to use sketch 7, I'm just going to click on that, and I'm going to go through all. And there you go. Now you can see that we have this nice cutout here. So if I ever wanted to actually cut this out on the water jet, what I would do is I would go to flat pattern here, and I would unsuppress this, and now you can see this turns into the sheet that I actually would have wanted to cut out. But I'm going to go ahead, I'm going to resuppress that because I like my sheet the way it is, all nice and bent. And so this would be the thing that you place on the front of your robot if you wanted to flip over another robot, or just disable it by keeping its wheels off of the ground and not allowing it to move anymore. So that's another type of device that you can use to attack another robot with. All right, and then the last thing I want to do is essentially make a spinner of some form. So I'm going to close this again. Again, not worth saving. Not worth saving. And so now what I'm going to do is make something that's going to spin. Now there's a couple of options here. Some of the things that you've seen maybe might involve some type of blade, but one thing that can be particularly effective is just a very quick spinning like bar or T-bone. And so let me show you what I have seen that has been relatively effective. So I'm just going to go to Extruded Boss Base, and I'm going to create yet another rectangle. And here, this is one of the simplest things that I've seen that has been actually insanely effective. I'm going to go ahead and I'm going to smart dimension this circle. This is a 1/2 inch hex, and then I'll smart dimension this side, and this is oh, no, not that. We make it 1.5 inches. So we make this something scary, like 6 inches, 8 inches, like the size of a wheel. Okay, this thing, if you got this up to speed, if you spun this around this hex hole here, this thing is very, very scary, and can impact a ton of energy into another robot. So, especially if I were to actually properly extrude it. So let me go ahead and do that, and I'm going to make it out of 1/4 inch aluminum because why not? Actually, let's make it out of 1/2 just for fun. Okay, so now this is a really thick piece of metal that could go spinning, and that could do some damage to a subsystem. Or we can do is we can put a like kind of a fork at the front of it, and so it could spin into another robot. So let me go ahead and do that. I'm going to put an extruded boss base on here, and I think what I can do is I can even make a flange of some form, or a 3-point. Let's make a 3-point arc. So I'll go from here to there, make something like that. And it looks like nothing right now, but it will look like something, I promise. I'm going to make this line perpendicular to that one. I'm going to bring this inwards there. And so one thing I'm going to do is I'm going to make that and that tangent to each other. So that's now forced to be tangent. I'm going to make sure that this pokes out by maybe like 3 inches to make it look especially scary. And it will look scary. Maybe 2. Okay. Now what I'm going to do is I'm going to take this and I'm going to mirror it. So I'm going to click on mirror. I'm going to click on that curve, and I want it to mirror about that line that I popped out there. Okay, that's done. Now all I have to do is so there we go. If I wanted to make this a little bit less ominous, I suppose I could probably shorten this distance so that I could bring it in a little bit more, so maybe I'll do that. Maybe I'll make this only 1 inch. And then bring this further inwards like that. And finally, a smart dimension from here to there. And make it 2.5 inches or so. Okay, great. So now I have a point there, I have a cusp here, and then the last thing that I want to do is I want to, suppose I can do a circular sketch pattern of this, and I only want 2 entities of it. Circular sketch pattern here as well. Okay, and then I just press OK, so now it's there. I'm going to exit this. I'm going to exit the sketch. I think. There we go. I'm going to click on these 2 contours, under selected contours here. And instead of doing blind, one thing that's really nice is going to up to surface, and then just telling the surface that you want it to extrude to. So I click on up to surface, then I just click on here. And now, up to surface, I click on the surface here. The circular sketch pattern and make that appear on this side as well. And generally that's a good idea, otherwise you'll have a lopsided entity that is spinning around at a high speed. Okay, so these are some of the general things that you can put on your robot. These first things should be the easy things to construct and the ones that you decide on. The hard part is going to be how you're going to start putting all these things on the robot. The importing of different parts into how to actuate them, etc., etc. So essentially that's going to be your job for the remainder of this class, essentially. So please email me if you have any questions, or if you have some difficulty making any of these kind of the more basic parts, or if you have questions on how to move forward on your assembly. All right, and that's it.